Hello and welcome to Miss Dairo's classroom. It's another learning time. Today we are going to be looking at how to find the LCM of two numbers using these three easy and fast methods. Come along with me. Let's look at the three easy ways to calculate the LCM of numbers. And to do this, we have to understand the three rules guiding this. The first is factor relationship. Some numbers have a factor relationship. The smaller number can divide the bigger number without remainder. This is called factor. In this case, the bigger number becomes the LCM. For example, if 3 and 12 are the numbers given, since 3 can divide 12 without remainder, the LCM is 12. The next rule, we have common divisor. When numbers given do not have a factor relationship, we check if they have a common divisor. That is there a number that can divide both numbers without remainder? If they have that, we then proceed to calculating the LCM using prime factorization method. This means dividing using prime numbers like 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. The last rule, we have no common divisor. When numbers do not have a factor relationship and also a common divisor, that means they have no common divisor. That is, they don't have a number that can divide both numbers without remainder. This is easy. We just multiply the numbers and we have the LCM. So if 5 and 7 are the numbers given, the LCM becomes 5 times 7, which is 35. Now let's begin with our first set of examples. The first says find the LCM of 24 and 8. Now what's our first rule? The factor relationship. Now does 24 and 8 have a factor relationship? Can 8 divide 24 without remainder? Yes, 8 can divide 24 without a remainder. Therefore, the LCM is equal to 24. The second one says LCM of 4 and 18. Now what's the first rule? Factor relationship. Does 4 and 18 have a factor relationship? Can 4 divide 18 without remainder? No, 4 cannot divide 18 without remainder. Now let's go to the second rule, which is a common divisor. Does 4 and 18 have a common divisor? Yes, they do have a common divisor. Now since they have a common divisor, that means we have to find their LCM using the prime factorization method. Now let's do that. So draw lines. Remember, we are dividing using prime numbers. We have our 4 and we have 18. So what's our first prime number? Our first prime number is 2. So can 2 divide either of the numbers? Yes. So we use our 2. 2 divided by 4. So 4 divided by 2, we have 2. 18 divided by 2, we have 9. So before we move on to the next prime number, we ask ourselves again, can 2 still divide either of the numbers? Yes, 2 can divide 2. So we have our 2 here. 2 divided by 2, we have 1. 9 divided by 2, 2 can divide 9, so we have our 9 here. So before we move to the next prime number, we ask ourselves, can 2 divide either of the numbers? No. We move to the next prime number, which is 3. Can 3 divide either of the numbers? Yes. So we use our 3. 1 divided by 3, we have our 1. 9 divided by 3, we have 3. So before we move on to the next prime number again, we ask ourselves, can 3 divide either of the numbers without remainder? Yes, it can. So use our 3 again. 1 divided by 3, we have 1, and 3 divided by 3, we have 1. So now we'll multiply all the numbers we use in dividing. So our LCM equals 2 times 2 times 3 times 3. 2 times 2 is 4. 3 times 3 is 9. And then our 4 times 9 is 36. That means the LCM of 4 and 18 is 36. Now let's move to the last example, which says LCM of 6 and 13. Let's start from the first row. Do they have a factor multiple relationship? No, because 6 cannot divide 13 without remainder. Do they have a common divisor? No, they do not have a common divisor. That means to get their LCM, we have LCM equals 13 times 6. And when we multiply our 13 by 6, we have 78, which means the LCM of 6 and 13 is 78. Now we move on to the next set of examples, and these I'm going to be a bit fast because we already know the rules. LCM of 33 and 9. 1, do they have a factor relationship? No, they don't. Do they have a common divisor? No, they don't. Okay, yes, they do have a common divisor, which is 3. So that means we are going to find the LCM using the prime factorization method. So quickly, let's do this. We have our 33 and we have our 9. So what's our first prime number? 2. Can 2 divide either of the number without remainder? No. Next prime number, we have 3. Can 3 divide either of the numbers without remainder? Yes. So we make use of our 3. 33 divided by 3, we have 11. 9 divided by 3, we have 3. So before we move on to the next prime number, can our 3 divide either of the numbers without remainder? Yes. So we use our 3 again. 11 divided by 3, we still have our 11. 3 divided by 3, we have our 1. So can 3 divide any of the numbers without remainder? No. So move to the next prime number, which is 5. Can 5 divide any of the numbers without remainder? No. We move to 7. Can 7 divide any of the numbers without remainder? No. We move to 11. Can 11 divide any of the numbers without remainder? Yes. So we use our 11. 11 divided by 11, we have 1. 1 divided by 11, we have 1. So our LCM equals 3 times 3 times 11. Now what's our 3 times 3? 9 times 11. And what's our 9 times 11? We have 99. So the LCM of 33 and 9 is 99. We move to the next one, LCM of 17 and 4. Do they have a factor multiple relationship? No. Do they have a common divisor? No, they do not have a common divisor. So to get their LCM, we are going to say LCM equals 17 times 4, which gives us 68. So the LCM of 17 and 4 is 68. The last one says LCM of 88 and 11. So the first row, do they have a factor relationship? Yes, they do, because 11 can divide 88 without remainder. So our LCM of 88 and 11 equals 88. Now your turn. You have to find the LCM of these numbers using the rules we've discussed today. So don't forget, send your answers in the comment section and I'll be right there to tell you if you got that right or if you need to make some adjustments.